College Algebra Exam 1 Review 1.1 through 2.8. Okay, so we're going to find f minus g of x and f divided by g of x of f of x is equal to x squared minus 5x plus 6, and g of x is equal to x minus 3. Now, basically, we're just going to directly plug in this stuff. So I'm going to do a lot of substitution here just to kind of illustrate what is happening. But you don't have to write all the steps I am. Let's use black. Okay, so we say f minus g of x. Okay, now what that really means is that's saying f of x minus g of x. Now what you do is you just substitute in, right? So again, f minus g, both in terms of x, is the same as f of x minus g of x. And then what you do is just plug it in. So where I see f of x, I plug in x squared minus 5x plus 6. That's what I plug in right here. I'm going to use parentheses to represent the fact that I'm doing substitution here. Plus 6. And then because we're subtracting, I put minus. And now it says g of x. Now I find g of x. G of x is over here, x minus 3. So I put x minus 3. There we go. Okay. So now I'm going to go in descending order of power and see what I can add or subtract. In this case, subtract. Now, if you find this confusing to deal with this kind of double negative over here on the right, what I would do is I would distribute that negative and flip all the signs. Then you don't have to worry about it. So you could either just flip all the signs or multiply everything by a -1. Same kind of concept. So you say -1 times x is negative x. -1 times -3 is positive 3, right? Now we can buy like terms. There are no other x squared or second power, so we bring it down. There is a -5x, and there is a negative x, and that's understood 1. So you do say -5 minus 1, which is -6x. Then you have constants of positive 6 and a positive 3, which gives you a positive 9, and so that right there would be your answer, right? Now it's kind of lazy, and I didn't keep rewriting the f minus g in terms of x, but that is all what this is right here. So again, my f minus g of x, and you can just keep on rewriting it because technically that's what you're solving there. Sometimes I'm lazy and just stick it on the end, right? Okay, so that is f minus g both in terms of x. So again, it's just a substitution thing. Wherever it says the f, you know that's the function f, and you plug in the function f. Wherever it says g, that's the function g, you plug in the function g. After that, you just do whatever arithmetic polynomial operation that it's asking for. There would be addition, subtraction, multiplication, or division. So the next one they're doing is division. Well, you kind of write the same thing. So this one's saying f over g in terms of x. Well, that's really the same as saying, well, f of x divided by g of x. Well, what is f of x? Well, f of x is equal to x squared minus 5x plus 6, and g of x is equal to x minus 3. Now, we want to simplify this rational expression. The way we're going to do that is we're going to factor everything first, and then we're going to see if anything cancels out. And the way we do that is I'm factoring the x squared minus 5x plus 6. It's a simple trinomial, meaning it has a 1 leading coefficient there, so it makes this a little easier. So the square root of x squared is x. It ends in a positive, meaning that because it has a positive 6 at the end of it, means they're going to match. They're matching signs, and because the middle term is a -5, right, the middle coefficient is a -5, they're both going to be negative. So matching, negative. Positive 6 matching, -5, both negative. Okay, now we're looking for two numbers that we can multiply together to give you a 6, positive 6, that if you add together will give you a -5. Well, that'd be a -2 and a -3, right? So -2 times -3 is positive 6, and so -2 times -3 is positive 6, and the -2 plus the -3 is equal to -5, right? So that's what I'm saying. So the multiplication matches the end, the constant, and the -5 matches the middle term, the -5. Okay, now, so we factored it out. Now we rewrite everything in factored form, and we are going to see if anything cancels out. And in fact, the x minus 3 cancels out, and that leaves me in x minus 2. Okay? And there we go. Now, the one I did over here, I did it vertically. Over here, I did it more of a kind of a horizontal notation. I mean, just use whichever organizes it better for you. They're both pretty good. Okay, so they asked us to do the subtraction. They asked us to do it, the division, and we got it. Okay, so let's move on to compound. Or composite, sorry, composite function notation. Okay, so this is asking a little bit different. So this is really saying we're going to plug the x into the f, giving us f of x. it's kind of f of x, right? And then what we're going to do is we're going to plug the f of x into the function g. And I'll explain what that basically means. You're kind of going from right to left. Or another way of thinking of it is that the composite function of g f of x that's kind of equivalent to g in terms of f x, like that, right? So this kind of means the same thing. That's the same concept, right? So what we could do is, so where there's the g, right, the g right here, right, it has an x squared. But what I'm going to do is I'm going to put a parenthesis, right, squared minus 2. And you can see there was an x right there, and that's where I'm going to plug in the f of x. And what is f of x? Well, f of x is equal to x plus 2. And I simply plug in the x plus 2 there, right? Now, this is probably an okay answer. And again, the problem with it is I did not write. I did not continue to write what this is actually equal to throughout, so technically that's kind of ugly. I can be a little better about that. Okay. What you could do if you wanted to is you could expand the x plus 2 squared. You don't always have to, but you could expand it. The pattern, I'm just using a pattern on this one, but that would give you something like x squared plus 4x plus 4 minus 2. And then you would continue to simplify this as x squared plus 4x, 4 minus 2, which would give you a plus 2. And I just used a pattern on that. If you don't like the pattern, I just used a pattern mentally on that, but let's say you don't know the pattern or you don't like the pattern, that's okay. You can expand it without the exponent of 2, which just means instead of writing x plus 2 squared, you'd write x plus 2 times x plus 2, and then you could just distribute, you know, all the terms, combine like terms, and you get the same result. You still end up getting this over here. I just used a pattern in this case. You don't have to, though. Okay, but this is what would happen if you distributed it and simplified it. You'd end up with something like this. Oops, that's not until like that. Okay, so I did the first one. Now, after you figure out what the compound of g and f of x is, composite, sorry, is what you would do is they're asking for the negative 2. Well, now that you already know what this right here is, now that you already know, let me rewrite it. My handwriting's pretty bad, I realize that. So we know what this is equal to, which is now equal to x squared plus 4x plus 2. If they just ask you, instead of having the x, they just want you to plug in there. That means x is equal to negative 2. Right? So that's all they're telling you right there, negative 2. They're just using function notation here. So wherever you have an x, now you're plugging in a negative 2. And then you're going to use order of operations to simplify this. So that's all that we're going to do now. Order of operation, we deal with the square first. Negative 2 times negative 2, or negative 2 squared is equal to 4. Okay. I'm just going to do one at a time, one step in the order of operation to avoid confusing. Obviously, you can kind of do more than one step at a time if you're at that level. So I did the square first, right? PIM-DOS, E for exponents, M for multiplication. 4 times negative 2 is negative 8. And then we have, so we get done with multiplication, division for PIM-DOS, and now we're down to addition, subtraction, from left to right, whichever comes first, right? So we're just simply saying 4 minus 8 is negative 4, negative 4 plus 2 is negative 2. So it looked like it's negative 2. And again, I need to keep bringing this down. I keep being lazy about that. That's on me. There we go. Okay, so it looks like we end up with a negative 2. There's an alternate way of doing this. I'm not doing this to say you should do it this way or this is a good way of doing it, but to kind of prove the point of what this is saying. If the compound of g and f of negative 2, then that must be the same as me saying what you could do is you could do this double plug in, right? So if I figure out what f of negative 2 is, right, and then whatever the result of that is, I could plug that into g, and that would give me the same kind of result. And this is I'm just trying to go over the algebra to show you this kind of the reasoning behind this. This might help you later on if you're going to go for a third math, but you can ignore this part. So for instance, f of negative 2, right? So well it would be negative 2 plus 2, right, is equal to 0. Oops, sorry. Yeah, negative 2 plus 2 is equal to 0. We plug the 0 in here, right? So, okay. And then what you would do is you would say 0 squared minus 2, which would just be 0 minus 2, which would be negative 2. And the point I'm trying to make here is that I also go to negative 2, right? So one way of doing this is and this is usually the better way of doing it, is you would solve for the actual algebra and come up with an equation like we came up over here, and then you plug it in. But it does kind of conceptually show you how this works in that if I just plug the -2 in the first, right? That's why I drew those little arrows first. If I plug -2 into the function f and then plug the result of that into the function g, then I get the same exact result. And that's kind of an interesting way of looking at the concept of how this actual compound function, or composite function works, sorry. Okay, so let's try the next one. What is the inverse function of f of x is equal to 1/2 x minus 5? Okay, so let's come up with the inverse function. Okay, so first I'm going to replace the f of x with a y. And then I'm just going to rewrite it. Just with instead of f of x, I turn it to a y. Next, I'm going to switch the x and the y. So that's going to turn, the y turns into an x, and the x turns into a y. And then I want to solve for the y. So I have to solve for the term with the y first. I get that by itself. So I'm going to add 5, undo the subtraction of 5 from 1/2 y. Now, if you want, you can get rid of the fraction first. That's probably not a bad idea. So let's get rid of the fraction first instead. What I did is not wrong, but if you want to kind of standardize it, I would probably want to get rid of the fraction first. So generally speaking, again, if I give you a function with a fraction and you're trying to solve, generally speaking, if you can get rid of the fractions first, you probably just want to get rid of the fractions, right? So then we say 2 times x is 2x, 2 times 1/2, right? So 2 times 1/2 y is just y, and then we say 2 times -5 is -10. Okay, now we solve for y, okay? And we don't have to deal with the fractions anymore, so we got rid of those. So hopefully that helps. Now, at this point, I'm going to undo the subtraction 10 by adding 10. Whatever I do to one side, I do to the other. Those cancel out. And that leaves me 2x plus 10 equals y. Okay, and now what we want to do is we kind of want to replace the y with that inverse. Okay, so this is the inverse. And what we would say in this case is that it is 2x plus 10. So this is the inverse, right? So that was the original function, and then that is the inverse of that function.